Hello, welcome to a panel on cutting through the hype of AI native 6G networks. I'm especially excited to be here today because after spending a decade on the operator side at Verizon, this is my second time on the other side of the table moderating a conversation. So that gives me an unique appreciation for how fast the technology evolves and how often the industry has to balance promise with practicality. So I've been told that AI RAN makes network self-optimizing, and I just hope that it can optimize my time management today as a moderator. We have about 30 minutes or so. Okay. Anyway, so when we talk about 6G, the phrase AI native gets used a lot, but what does it actually mean? Is it a fundamental architectural shift, or is it just a layer of intelligence applied on top of existing networks? And more importantly, how do we separate genuine innovation from the marketing spin? So our goal today isn't to simply speculate about the future, but to pressure test ideas, expose risks, and uncover the opportunities that will shape how AI and 6G converge. So with that, let's dive straight into the discussion. My name is Nirlay Kundu. I work at IMDEA Networks, a research institute based out of Madrid in Spain, and I work in the telco standards. And first, let me introduce you to the panelist. Alex, can you go ahead, please?
Thank you, Nirlay. This is Alex Choi from SoftBank, and I'm also chairing the AI RAN Alliance.
Awesome.
Thank you for having me.
Thank you. Yue?
Hello, this is Wang from China Telecom.
Thank you, Yue. Alexandros?
Hello, everybody. My name is Alexandros Kaloxylos. I'm the Executive Director of the 6G Smart Networks and Services Association.
Thank you. And lastly, Ali?
Good day, everyone. My name is Ali Tizghadam. I'm the TELUS Fellow and a Chief Architect for the automation.
Thank you. All right. So just to start the ball rolling, so fundamental question. So what does AI native mean to you? So what does AI native mean for the 6G architecture that's fundamentally different from just having a very good AI ML in the 6G network, right? So I'll ask Alex Choi, please, to take a stab at this.
Okay. So from my perspective, AI native is not just adding AI on top of today's networks. It's a complete shift in how we design the system. The network is built from day one with the intelligence at the core, not as an optional add-on. So what that means is we should have a data collection or telemetry, which is always on, and data is structured, so it's ready for learning. And every layer of the network, from device to RAN, RAN to core, core to cloud, has built-in hooks for intelligent actions. And think of it like building a nervous system first, and then the body. And instead of separate optimizers, we move to a shared knowledge layers where all part of the network can learn from each other. So the goal is a control system that's intent-driven and flexible, where models can be plugged in and out as needed. So just to summarize, deeply embedding AI from the very beginning to build autonomous and intelligent networks is exactly what I mean by AI native.
Great, thank you. So the key takeaway is, it's built from scratch, like AI embedded in the architecture and design itself. Yeah, fair enough. So the same question goes to Ye. So what's your point of view, Ye, on the AI?
No, I agree with what Alex just mentioned. It's to me, it is about the inherent design of the network to accommodate AI end-to-end across the network. And one aspect I might be able to add on top of it is it is not only about using AI machine learning to enhance network operation management. It is not only about integrating the AI models into the network, it is also about how to design the network in order to better provide the AI services. So the emerging AI services on top of the network, how do you actually design that network from day one to be able to better accommodate those service requirements?
Great. So basically, both of you said then, it's embedding AI from day one, and not kind of add on later on in the life cycle. Yeah, fair enough. Yeah. So that's great. So, but yeah, so once we define, what AI native is, so the next challenge is separating the genuine progress from the marketing spin, right? I would say the hype versus reality check. Now, given that many operators are still struggling to fully automate and monetize their 5G cores and still deploying the 5G cores, right? So why would we believe that AI native is anything more than, it's a vendor-driven hype cycle to sell new hardware, new software? So maybe I'll direct this question to Alexandros, please.
Yes, sure. I don't think that it is only a vendor request or desire. I mean, also the operators seem that they target to achieve, for example, energy efficiency or improve the performance of the network, or even monetize, as you rightly said, that exposing AI as a service to the applications, it's something that is desired, to my understanding, also by operators. Of course, I fully agree with you that we live in the hype of what AI can do, and people may believe that this is a panacea and solve all the issues. So one of the lessons that we have learned from the 5G is that we have to take care of some sensible design this time. So where exactly to apply, which flavor, and how demanding the AI is going to be needs a lot of discussion and careful considerations.
Yeah. Great. Yeah. So I mean, it's clear that the potential of AI is enormous, but we also know that the cost of building and training AI models aren't trivial, right? So this brings me to the economics. And now the large foundational AI models proposed for 6G are, incredibly computationally expensive to train and run, right? So, isn't there a fundamental tension between deploying these massive energy-hungry AI models like everywhere and the telco industry's crucial goals of reducing the total cost of ownership and achieving uh, rather net zero energy targets? Now, as you know, that the telco industry is a very, I mean, hardware intensive, capital intensive, and very low margin business. So my question is kind of along those lines. So maybe Alexandros, you can take a stab at this, please.
Yes, indeed. That's a crucial thing. We all know that AI is energy consuming. I mean, it requires a lot of resources in energy. But as I said before, there are different flavors of AI. Now, in my opinion, one could consider a centralized approach where you have a supercomputer to collect all the data and analyze and everything. But there are also distributed approaches. So having the AI at the edge, for example, having the AI even as an assisted mode from the far edge or even the devices. So we need to find a trade-off there. Of course, we cannot say that AI can be used in a centralized mode, and this is the only way that we can do this. We have to carefully select, as I was saying before, make some sensible design choices on what it makes sense at the end of the day, what we want to bring into the network, considering that we want to optimize the network operation, provide AI as a service, but at the same time, have this in an energy efficient way.
Sure. Great. Do you want to take a stab at this, same question?
Yeah, sure. I mean, yeah, it is fair to say, training is very costly and consumes a lot of power. But I think the key for us is to shift our perspective from having this brute force AI to become the efficiently deployed and the intelligent AI. So I mean, what we believe is bigger is not necessarily better. I think telecom is actually a quite specialized industry. So what we are looking for is not, a massive monolithic foundation model at every place of the network, but I think it's probably the right size and the specialized models, smaller and specialized models where it is highly efficient and fine-tuned for the specific network tasks. For example, prediction handovers, it probably doesn't need a massive, foundation model to do that. And I think Alexandros also mentioned that the distributed intelligence hierarchy. So you can actually offload some of the computational tasks according to the context of the network and the availability of the computational resources. So maybe at the core, at the device side even, and there are technologies that are being developed, for example, tiny machine learning and also the hardware acceleration. Those are all the advanced techniques to help us to head towards for having a more efficient AI models for the network operation and management to be better integrate efficient AI into the network, not necessarily massive AI models into the network.
Sure. And a follow-up question. So do you think, this type of thought process is happening now in the 5G advanced realm? Or is there a distinction between, 5G, 6G?
Well, I think it is. I think, well, at least we in the industry, we realize, when it comes to AI native, it basically means you have lots of AI models, big or small, deployed in the network, and you need to consider the cost issue from day one. And then in order to avoid the massive cost at a later stage of deploying the AI models, you will need to take some advanced technologies from the model side, for example, model compression and how to distribute the computational tasks. Those are all being considered.
Great, thanks. So yeah, we talked about the cost and but in today's environment, so every investment comes with the pressure to show quantifiable returns, like measurable returns that you can see in the balance sheet, right? And so how do operators justify AI at scale? And as a telco operator, so your shareholders care about the revenue, the profit. So can you lay out a specific credible revenue stream or a business model that only an AI native 6G network can enable? So what's the niche of this AI native 6G network that couldn't be done with AI on the 5G network or 5G advanced network? So I'll throw this question to Ali, if you will.
Sure. So let me look at the problem from a slightly different angle. If you look at the history of telco services, we used to sell what we call long life cycle products, things like internet, mobility, TV. Those services are provisioned once and run for years. That's why manual or semi-manual operations were enough for us. But the industry nowadays is shifting. Services are now short-lived, they are dynamic and contextual. So for example, a slice for 2 hours sporting event or a bandwidth calendaring for a gaming tournament or a mission-critical connectivity for a remote surgery, right? Those are examples of the services that are on demand today. They are not set and forget type of services. They are ephemeral, they are high value, and they are SLA critical. Now, if we consider that the only way to monetize this kind of demand is with autonomous assurance and operations. So basically, having AI native infrastructure is not a Christmas wish list anymore. It's a necessity. But when I want to look at it from the revenue angle, here is exactly where, in my opinion, the real opportunity lies as well. Once we build an autonomous network fabric, we can expose it as a platform via telco APIs that are getting more and more popular nowadays, and let the enterprise directly compose what their services, business to business services, even B2B2C services. For example, consider a logistics company guaranteeing latency for a supply chain, or a media company spinning off ultra-low latency slices for immersed content, right? So the return of investment is not just about the cost saving, it's about turning the network into a programmable platform, unlocking the new categories for enterprise. And that cannot be done without rebuilding the way that we are looking in the telco from the platform perspective, and that's AI native.
Great. So, Ali, you're saying that, these new revenue streams that will be generated, and there would be some kind of niche users who are willing to pay for this, this extra services, these niche services, correct?
Yeah, we do have customers coming and asking for these type of services as we speak, right?
Great, great, great. No, it's a great point of view from an operator perspective. Great. So now, we are, as we chase the return of investment, there is another concern. Like, are we at the risk of just replacing one form of locking, vendor locking, to another form of vendor locking? So, how real is the vendor dependency problem in the AI native world, right? So the vision seems to require incredibly deep integration between the hardware, software, different layers, and the AI models. And so doesn't pursuing this AI native architecture inherently risk creating the ultimate form of vendor locking, making you completely dependent on a single stack, single vendor's proprietary stack? So how do you plan to avoid this? So, Alex, can you please take a
yeah, sure.
Yeah.
The risk is real. Indeed, avoiding the vendor lock-in has been one of the top priorities for industry groups like O-RAN Alliance, 3GPP, and AI RAN Alliance. The solution itself is principle very simple. Keep interfaces open. So we don't standardize the AI models itself. Rather, we standardize the contracts, the intents and telemetry, and the APIs for actions. So vendors compete on how well they meet those contracts, but the interfaces stay portable. This is why, for example, O-RAN Alliance, their work is so important. Standardizing the interfaces such as R1, A1, E2, Y1, and defining how the RIC, RAN Intelligent Controller, accepts RFs, and the SMO, Service Management Orchestration Framework, talk to each other. The SMO lets operators mix and match apps from the different vendors. It's built for plug and play in a multiple vendor world, so no one is locked into a single stack.
Great. So a follow-up question, just being a devil's advocate here. So you mentioned about the interfaces open, fair enough. Yeah, O-RAN Alliance, promotes these open interfaces. But do you think all the vendors are using the open interfaces, or they're just, or rather the telcos, are they using the open interfaces, or they're just there and it's ultimately the proprietary interfaces are being used? So any comment on that?
In that regards, the operator's role is going to be critical. So the operator should put this, compliance requirements, open interface compliance requirements in their RFX. So that way you can, you can you can force the vendors to comply.
Exactly. Yeah. That was also my understanding of feedback from my Verizon days. Like, the operator should drive that, open interfaces from the vendors, and so it's some of the open interfaces may be used, and some of them may not. So yeah, great, thanks. So then let's move to the question about the pace of innovation and standardization. So Alex, you come from the standards, great background. So industry thrives on the collaboration and standardization, but AI moves far faster than standardization processes, right? So how do we reconcile innovation with the speed of, for the need for interoperability, right? So and by the time 3GPP finishes standardizing the AI interface or framework, right? Won't it be already obsolete? I mean, or shouldn't AI be left to the competitive in the vendor environment for the fast-moving vendor ecosystem rather than being standardized? So I'll ask Alexandros, please, to comment on this.
That's a valid point, but I have to say that introducing AI to the networks, it's not something that has just started now. It's taking place for some years. For example, if you see in 3GPP, in the first release of 5G, there was this small box which was called Network Data Analytic Function, not doing too many things. In the follow-up releases, we see that this is picking up the pace, extending, etc. So I'm feeling quite confident that, and I fully subscribe to what Alex said before. I mean, standardization is the issue. It's something that indeed it takes time, but it's the only way, in my mind, to have interoperability and guarantee interoperability. At the same time, I think that we need to come up to a level of maturity on the provided solutions at such a level that the operators will trust and use them. Because going directly to full automation without having full guarantees what is going to happen when the AI takes over the network, it still requires some extra time. For example, in Europe now, we are having this large framework, which is called Smart Network and Services. We have roughly 80 projects. Most of them are doing something about AI. We have 110 new ideas on how to optimize the network or how to expose AI as a service to the developers. And this is indeed in the research level. So things are converging quite nicely right now. Of course, I can refer also to the activities from the Oral Alliance, not only 3GPP. So things are picking up pace. And I think that our community globally has the experience to manage these kind of things. So it's not like something is going to happen next week. It's going to take some time. And of course, we need to follow established process like standardization of interfaces. If I may add only one thing, it goes without saying that standardization is extremely important. But if we over-specify which interfaces have to be standardized, we may need to see a trade-off. If you open everything, all the components are going to be standardized, you may keep innovation.
Yeah.
So it requires, the global collaboration in these aspects.
Yes, it needs a balance. Fair enough. Yeah. What's your take on this?
Yeah, I completely agree. I think it's we need to have the right balance between allowing the innovation and not to over standardize, but also to be able to have that stable and interoperable foundation. So we prevent the fragmentation. So you can't leave that all to the ecosystem of the developers and the vendor ecosystem, because then every vendor would create their priority AI hooks, and then that makes the multi-vendor integration nearly impossible. It also has something to do with the scalability of your solution, right? I mean, what we need to look after in the standard. It is future-proof enough, and it is also flexible enough. The architecture needs to be flexible enough to be able to accommodate the fast-moving AI technologies. So we can allow, and ensure basically the AI advances can be deployed at a scale across the network and vendors, and without fragmentation. So I think standard still plays a very important role. It just needs to be adapted given the fast pace of AI advancement.
Sure, which leads to a philosophical question. So, if the value of AI is in its unique competitive differentiation, what exactly are we standardizing? Isn't there a risk that standardizing interfaces and the data models for AI will simply create, lowest common denominator of intelligence, which will stifle the innovation and the growth of the AI native promises? So, I would like to ask this question to Ali, please.
Sure. I don't think we are standardizing intelligence itself. That's impossible. And even if it is possible, as soon as you do it, that I wouldn't call it intelligence anymore. What we are trying to standardize is the grammar, the data formats, the APIs, the way that we are interfacing with the intelligence, the accountability layers. Those are, we are trying to standardize to ensure interoperability, but without stifling the innovation. But there is a catch here that I would like to talk a little bit about. The AI native introduces new risks, like agents acting beyond the scope. We have all heard about this new concept of orphan agents, right? So a couple of months ago, in one of these online code development companies, they reported that an AI agent ignored the guardrails and deleted a live production database with more than 1,000 of executives and companies' information in it. And even after that, try to hide it, right? So basically, this concept of orphan agents that are acting outside of the intended scope is emerging. It's a real danger. And by the way, it's what we have created. We aimed to create AGI, and here we are. AGI is getting closer and closer to human behavior. And because of that, we do need to standardize and find the ways to create standard frameworks for what I would like to call intent verification. So we should standardize verification mechanisms. For example, nowadays, we keep hearing about network digital twin. One of the primary users for network digital twin, if it built properly, is to safeguard that part and to make sure that we are verifying the intent, which is behind the intelligence that we have created.
Great, thanks, Ali. And kind of a follow-up to that is, see, the telco needs data to train the AI, but also we need to protect user privacy, right? As an operator, so will you be willing to open your valuable network data to the vendors and competitors to train industry-wide models, right? And how can you create the frameworks for data sharing that does not validate the regulatory rules like GDPR, etc., and create massive security risks, right? So I'll ask this question to start with Alex, please.
Yeah, sure. This is a classic data dilemma. We need the data, but we also need the privacy and security. There are several approaches. For example, federated learning, where the raw data never leaves the operators. So the model updates, for example, gradients or metrics, are shared. So sensitive information stays local. And secondly, we can use synthetic data, so which means we generate privacy safe and statistically accurate data sets for testing and training without exposing the real customer data. And on top, we may also think about the minimization and anonymizations. we only collect and use the minimum data needed with the clear rules on purpose and retentions. Last but not least, there is a privacy enhancing technologies where we use secure enclaves and other tools for any cross-organization computation. So this way, we get the benefits of collaborations without violating privacy.
Great, thanks. Alexandros, do you have any thoughts on this?
Yeah, indeed. Actually, it's one of the topics that we have been discussing lately in Europe when we are working to set up a collaboration environment in the SNS. It is as Alex said. I mean, we're talking. It's going to be challenging to have real data from the operators. That's why synthetic data or data from emulators or experimental platforms that are quite advanced. So you need to have a significant coverage, number of base stations, number of users, etc. Digital twins is another solution, simulators, where you can have data created, but those that are well aware of what is happening. These mean operators, vendors, and even vertical service providers. So somebody has to be able to validate which data are indeed suitable to train AI models. This is a global issue, to my knowledge. And honestly, if we want to also be able to evaluate the solutions that even are going to be discussed somehow, even their influence to the architecture, we need some benchmarking data that can be used and we can have some replicability. So it's a very important issue and definitely something that we need to come up with solutions. Otherwise, it's going to be on bilateral basis between operators and specific service provider, etc. But if we want to do it at a more wide level, there are solutions, and currently we are working to provide this data, to create this data, actually.
Great. I think we're running out of time now, so thank you all for a very thoughtful discussion. So what's clear from today is that AI native 6G is more than just a technical ambition. It's a balance of economics, trust, openness, and innovation. So we have seen that the hype is real, but there are also a lot of challenges. And the real test will be how we turn these bold ideas into deployable, interoperable systems that deliver measurable value for operators and for the society. And the road ahead is complex, but with collaboration and clarity between the vendors, operators, cloud providers, so we can shape this AI native 6G into something truly transformative. Thank you all.
Thank you very much.
Thank you.
Thank you very much.